Jeev draws a regular hexagon, then Mira connects the midpoints of the sides of Jeev's hexagon to form another regular hexagon as shown. What is the ratio of the area of Mira's hexagon to the area of Jeev's hexagon? So what we can do is, if I name the outer hexagon as Jeev's hexagon, and so the inner hexagon is Mira's hexagon, and so they are the midpoints. These are the midpoints, so they're all equal because it's a regular hexagon. And if we are to have a center, so the hexagons will have the same center. So if I have a center here, and if I join, so first let me find the area of Mira's hexagon. So if I were to join the centers to the vertices, so then I would have 6 equilateral triangles because this is 60 degrees, and the internal angle of the hexagon is 120 degrees, so that's 60 and 60. So if I were to name or to call the the length of the sides as x for Mira's hexagon, is x, so then area of Mira's hexagon would be root 3 out of 4 times x square. So that's the area of an equilateral triangle, and multiplied by 6 because there are 6 equilateral triangles. So then we can call Jeev's hexagon. So if this each side was y, we can say that length of side for Jeev's hexagon is y. Therefore area would be root 3 out of 4 y square multiplied by 6. The problem is, how do we connect x and y? So what we can do is, we haven't really drawn the y's, so I will draw them. If I can take off some of these lines, and then I can draw the lines. So then you see all of these is y, and this is y out of 2, y out of 2, and this line here was x. This is x. So if I were to name the O and A and C, okay, so and A, not x would be confusing, A, B, C. So OB is perpendicular to AC. So OB is perpendicular, I should write it, is perpendicular to AC, and that's because OAC is not isosceles, it's equilateral, which is same as also an isosceles triangle, equilateral. So OB is perpendicular, and you would then have angle OAB is 60 degrees, and we don't need to do the 60-30, but still, so then angle AOB would be 30 degrees. And of course angle OBA is 90 degrees, is equal to angle OBC. But we can, I didn't need to write this, but I just wrote it. But because we can apply Pythagoras theorem, we don't need to apply trigonometry here. So I can probably cancel it out, or I'll leave it there. So applying Pythagoras theorem, we can say that OB square plus AB square is equal to OA square. So you can say x square plus AB is y out of 2. So you can also write AB is y out of 2. So plus y out of 2 whole square is OA square, which is y square. So that would imply x square is y square minus y square out of 4. That is 3 out of 4y square. So we know what x square is. So let us substitute the value of x square in area of Mira's hexagon. So area of Mira's hexagon is equal to root 3 out of 4 times, instead of x square, I can write 3 out of 4y square and times 6. So I can simplify it, but I will hold on to that. Okay, so I will just write 6 times 3 is 18, root 3 out of 16 y square. So now you see both Mira's and Jeev's hexagon we have in terms of y. So I can find the ratio of the areas. So then I will write ratio of area would be Mira's hexagon. So the area of Mira's hexagon has to be numerator. So that is 18 root 3 out of 16 y square, and then divided by Jeev's hexagon, which is root 3 out of 4 y square times 6. So I can write this as 18 root 3 out of 16 y square multiplied by 4 out of 6 root 3 y square. So then I can cancel the y squares and the root 3, and the 6 times 3 is 18, and 4 times 4 is 16. So I am left with the answer, which is 3 out of 4. So that is equal to 3 out of 4. So the ratio of the area is equal to 3 out of 4. And that is the answer.